Here what we're going to be talking about specifically are the maximums and minimums of the quadratic functions. Basically, the vertex will tell us where the highest or lowest point of the quadratic function is, or the parabola. We recall if a was greater than 0, then the parabola opens upward and it's going to have a minimum at its lowest point. If a is less than 0, then the parabola opens downward and the vertex would be at the highest point where its maximum is located. We can figure out the maximum by using our formulas for the vertex with negative b over 2a. So if I look at this first function, f of x is equal to 3x squared plus 6x minus 13. What I'm going to do is identify that a is equal to 3, b is equal to 6, and c is equal to the negative 13. So since a is equal to 3 and it's positive, it's going to open upward and have a minimum. We can figure out where the minimum point is by looking at the vertex. So for the vertex, we look at negative b over 2a. That would look like negative 6 over 2 times 3, negative 6 over 6, or just negative 1. So that's the first part of the vertex. We put that into the function and calculate the second part of the vertex. So we'd have 3 times negative 1 squared plus 6 times negative 1 minus 13. That comes out to be negative 16. So we now know that the minimum point is going to be at the point negative 1 comma negative 16. Another question you might encounter when talking about quadratic functions is what its range might be. Not looking at the full graph, let's say, but just looking at the information about the minimum, can we tell what the range of the function is? We actually can. Let's just think about what would be going on with this one. If we had a minimum point down at the point negative 1 comma negative 16, and the parabola opens up, something like this, let's say, then the range would be the entire span of the y-axis where it stops down at the bottom, and then it goes all the way up from there. So thinking about the y-axis with our parabola, we know that it goes all the way down to negative 16, and then it goes up toward positive infinity. So the range, once you know where the minimum is, here would be negative 16, comma, infinity. Let's look at another one here that goes negative 3x squared minus 12x plus 1. And we have an a is negative 3, b is negative 12, and c is negative 1. We check that the a number now is a negative number, and so this thing is going to open down, and we'll have a maximum point. We can figure out that maximum point by figuring out the vertex. So negative b over 2a would go negative 12 over 2 times negative 3. Negative 12 would be positive 12, but here divided by negative 6. So that would equal to negative 2. We'll plug that back into the function. We'll get negative 3 times negative 2 squared minus 12 times negative 2 minus 1. That all comes out to be positive 11. So this one has a maximum at the coordinate of negative 2 comma 11. I'll go ahead and mention about its range, just in case that's part of any questions in the future. In this case, though, it's a parabola opening downward from its vertex at 2 comma 11, since that's up at the maximum. So however it opens up here, it has to go something like this. which means now its range for the y-axis is now heading downward from the 11 at the very top. So the range here would look like parenthesis negative infinity, comma 11, close bracket. This question is more of an application situation. It says, when an athlete in a shot put competition throws a shot at a 65-degree angle, its height, g of x, in feet, can be approximated by the function g of x is equal to negative 0.04x squared plus 2.1x plus 6.1. We're going to use this to answer a few different questions. The graph is also given here as well to help us understand that the object that's been thrown is following this trajectory. And the trajectory follows along a parabola, which is our quadratic function that we have here, g of x. The first question is, what is the maximum height to the nearest foot, and where does it occur? So it has to hit a high point right here somewhere. And so how we're going to calculate that is by using the vertex. So to get the vertex, we're going to be doing negative b over 2a. Our a in this case is negative 0.04, our b is 2.1. In case we need it, the c is equal to 6.1. So this would look like negative 2.1 over 2 times negative 0.04. When I did that calculation, I came out with 26.3 for 26.3 feet. So what that tells me is that how far forward it took to get to the highest point is 26.3 feet, somewhere in there. Now I want to know, okay, how high was it at 26.3 feet after it was forward from where it was thrown? I do that by calculating g of 26.3. So I have to plug that into the function. Plugging into the function will look something like this. I just had to run the calculator through that, and I came out with 33.7 for 33.7 feet. So up here, where it got to the highest point off the ground, it was 33.7 feet off the ground. So that's the first part. Second part says, what is the maximum distance the shot travels? So now we want to know, how far was it till it hit the ground? That is going to correspond to the x-intercept. In this case, since our graph is set up where the x-axis is the ground, basically. So let's figure out what the x-intercept is here. As we've done before, we have to set it all equal to 0. Negative 0.04 x squared plus 2.1x plus 6.1. Now this thing, we're going to have to apply the quadratic formula in order to solve. So when I set up the quadratic formula, it would look like negative 2.1 plus or minus the square root of 2.1 squared minus 4 times negative 0.04 times 6.1 all over 2 times the a value, which here is negative 0.04. Now this is quite a bit of number crunching to do. We're just going to let the calculator handle it for us. So here's what it looks like when I plugged this thing into the calculator. I had to plug it in two different ways, one for plus and one for minus, because we had, again, plus or minus in the quadratic formula. So you can see how it was entered in and the two different values that were received. One of them, however, is negative. That doesn't make sense in the problem to have a negative distance forward. So we're going to use this number right here. So it would have traveled about 55.3 rounded off feet forward until it hit the ground. The last question asks us, at what height was it released? So basically, when it was let go of, how high was it off the ground then? We can actually determine that by finding the y-intercept. So we can plug in 0 for x and get that number. It would look like 0. Inside there would be negative 0.04, 0 squared, plus 2.1 times 0, plus 6.1. And that's actually all just going to be equal to 6.1. So that would tell us it was 6.1 feet off the ground when it was released.